Welcome to The Explainer. Today, we're tackling one of the absolute biggest headaches in AI engineering right now, exploding context windows. Seriously, if you've spent any time building with large language models, you know the exact pain I'm talking about. You wake up, check your API bill, and it looks like a mortgage payment just because of your token counts. Well, we're going to explore a truly fascinating solution called the Headroom SDK. It's designed specifically to solve this exact problem by auto-compressing your LLM context. So, I want you to imagine a scenario for a second. What if you could compress your entire LLM context with just a single line of code? No, literally, just one line. For all of you developers out there actively maintaining complex apps, I know for a fact the very last thing you want to do is rip apart your beautifully architected TypeScript or Node.js codebase just to save a few tokens. You need something plug and play, right? Well, that plug and play magic is exactly what the Headroom SDK delivers. Section 1. The context bottleneck and the universal solution. Okay, let's dive into this. If you're building agents or complex AI workflows today, you are absolutely using tools. And, well, here's the harsh reality of that. Tool results and massive JSON payloads are just aggressively eating up your context limits. Every single time your LLM calls an external API, or pulls a database schema, or reads a giant log file, it just dumps these massive raw JSON arrays right back into the prompt. It completely bloats the context window, it drags down response times, and man, it just drains your wallet. It's a massive pain point for basically any production-grade AI app. Enter our hero for today's explainer, the with Headroom wrapper. This is a single-line function that wraps right around your existing LLM client. Honestly, it acts almost like a magic trick. Before your messages even have a chance to reach the LLM provider, this wrapper intercepts them. It auto-compresses them, sleekly slashing your token count, all without changing how the rest of your application behaves. It's pretty wild. Which brings us to Section 2, under the hood, the proxy mechanism. Let's pull back the curtain and see exactly how this is happening. So the foundation of this whole system relies on a local proxy server. Here's the catch, but it's actually a really clever one. Before you even initialize the SDK in your code, you absolutely must have the local Headroom proxy running. The actual heavy lifting, the compression itself, happens locally. Your SDK is just going to route your messages to the proxy's /v1/compress endpoint, shrinking that payload way down before it ever travels over the internet to OpenAI or Anthropic. It keeps the whole architecture super clean and localized. And this whole thing builds into a really precise 4-step lifecycle that happens in literally milliseconds. First up, the wrapper extracts your messages and converts them into a standard OpenAI format. Second, it fires that standardized data over to your local Headroom proxy to get compressed. Third, it takes those newly compressed messages and reverts them right back to whatever original format your specific SDK actually requires. And finally, step 4, it forwards that optimized request straight to the LLM provider. So basically, it intercepts, shrinks, translates, and sends. Moving on to Section 3, Implementation 1, the Anthropic SDK. Let's see this applied in the real world. When you wrap your Anthropic client with Headroom, it acts like a very, very precise surgeon. It safely intercepts only the client.messages.create call. That's it. It doesn't rewrite your entire SDK client. It just waits for the exact moment you're about to generate a message, pauses the execution, runs that 4-step compression lifecycle we just talked about, and then just lets the call proceed as normal. And this brilliantly illustrates that translation step I mentioned earlier. You see, the compression engine natively speaks OpenAI's format. But as we know, Anthropic uses its own content blocks, right? Things like type text and then the text content. Well, Headroom handles this seamlessly. It temporarily translates Anthropic's block format into OpenAI's standard rule and content format, compresses it, and then translates it right back. Crucially, and this is a big deal, this conversion is completely lossless. Not a single drop of context gets accidentally destroyed in translation. Now, what's actually really interesting here is what doesn't change. As a developer, I know introducing a new wrapper into your code can be terrifying because you're always worried it's going to break something else. But here, all the other SDK methods, they just pass through, totally untouched. If you rely on streaming responses from Claude, they work perfectly normally. Your app's request and response behaviors remain absolutely identical to an unwrapped client. Literally, the only difference is that your payloads are way smaller. Section 4, Implementation 2, the OpenAI SDK. The pattern here matches exactly what we just saw with Anthropic. But instead of the messages endpoint, the with Headroom wrapper specifically targets chat.completions.create. It extracts the messages out of the request parameters right before that network request is fired off, zips them over to the local proxy, and then swaps out your original bloated messages for the sleek, compressed versions. What you really should take away from this is just how smart this wrapper actually is. It explicitly knows not to touch non-text data. If your application is making API calls for embeddings, or generating images with DALL-E, or processing audio, Headroom completely ignores them. Those requests pass straight through to OpenAI exactly as they normally would. It is strictly hyper-focused on optimizing your text and chat context. So the crucial point is understanding where this actually moves the needle for you. Think about the breakdown of your content types. For your standard, everyday conversational chat messages, you're going to see a moderate impact. But for the heavy hitters, tool call logs provide high savings, and large JSON arrays yield the absolute maximum savings. If you've got agents out there dumping raw database queries or the absolute horror, raw web-scraped HTML into your context, this is exactly where Headroom truly shines and reclaims your tokens. Let's jump to Section 5, Implementation 3, the Vercel AI SDK. Now, instead of just giving you one option, the official specs actually detail 3 distinct integration patterns for Vercel. First, there's that familiar with Headroom one-liner, which just wraps the language model directly. Second, if you've got a slightly more complex setup going on, you can use Headroom middleware to compose it perfectly alongside your other custom middleware. And third, if you really just want raw absolute control, you can use compress Vercel messages as a standalone function in your custom data pipelines long before you ever even touch a model. This right here is arguably the absolute superpower for Vercel users. Because Headroom integrates at the SDK level, that one-liner works with literally any provider you are routing to through Vercel. Whether you're using the OpenAI package, the Anthropic package, or even the Google package, the compression works universally. You write that optimization logic exactly once, and it applies no matter which model you decide to query on the backend. It's brilliant. And once again, your peace of mind is guaranteed here. Critical Vercel features are completely unaffected by this upstream compression. If you're relying on stream text for snappy, real-time UI updates, or generate object to force those strict structured JSON outputs from the LLM, they just continue to work flawlessly. The proxy handles the context optimization completely invisibly, letting Vercel handle the generation exactly the way you designed it. Finally, Section 6, Summary. Let's wrap this up. We have covered a lot of ground today across the Anthropic, OpenAI, and Vercel ecosystems, which brings us to the final thought I want to leave you with. If you are currently dealing with heavily bloated context windows, if you are actively hesitating to give your AI agents more tools just because you're terrified of the token costs, how much time and money will you actually save by crushing those payloads with a single line of code? Honestly, it's a question worth answering. Go check your logs, look at those massive JSON arrays, and see what a real difference that local proxy can make for your own projects. Thanks so much for joining me for this explainer, and keep building.